Jupiter's 4 largest moons have drawn our attention for centuries, ever since Galileo spotted them with his homemade telescope. But they've gotten especially interesting to us over the last few decades, as astronomers have discovered that at least 3 of them likely have underground oceans of liquid water, while the 4th may have an ocean of magma. Scientists once assumed that they had Jupiter's gravitational forces to thank for heating the moons enough to have liquid oceans. But researchers now think that the moons themselves actually keep each other warm. Now, it's not exactly easy to study an underground ocean, especially when it's on a moon hundreds of millions of kilometers away. But scientists have been able to learn about these oceans through clues like cracks on the moon's surfaces, patterns of dissipating heat, and variations in magnetic fields. And they've concluded that these liquid and magma oceans are caused by tidal heating, which essentially works like this. Say you have a moon in a tight orbit around its planet. The part closest to the planet will feel the strongest gravitational pull, while the part farthest away will feel the weakest pull. That difference will stretch the planet along a straight line between the moon and the planet. So as the moon both spins and moves around its orbit, it'll stress and compress as the point closest to the planet changes. All this stretching creates friction, and that releases heat. This happens to some degree on any object in an orbit, but there are 2 factors that affect the size of these so-called tides: how close it is to whatever it's orbiting, and how massive that other object is. In the case of Jupiter's moons, scientists figured that since Jupiter was so massive and close by, it was surely responsible for creating the tides that heated up these bodies. But according to a study from July 2020, Jupiter may not be doing it alone. As small as they are relative to Jupiter, the moons may actually have an important role to play in keeping each other warm. The key has to do with the timing of the tidal tugs from the other moons. See, every oscillating object is naturally tuned to resonate or respond most strongly to forces that repeat at a specific frequency. This is called its natural frequency. Like when you're on a swing, you have to kick your legs at just the right interval to keep yourself swinging. That's the swing's natural frequency. And as weird as it sounds, the oceans on Jupiter's largest moons also have natural frequencies. It's a little less obvious how you can think of a moon as oscillating, but basically, as the point closest to Jupiter moves across the surface, the moon repeats a cycle of stretching and resting. That cycle is the oscillation. And the moon's natural frequency depends on 2 main things: their mass and the depth of their oceans. Because here's the thing, whether it's water or magma, the presence of a body of liquid changes the way an object responds to gravitational forces. When a moon gets a gravitational tug from another object, everything bulges, or tries to bulge, in the direction of the pull: rock layers, any atmosphere, and any liquid. As the direction of the pull changes, that bulge moves across the surface in a wave. And the deeper the ocean, the faster the wave moves. That's because in order for a tide to rise, the water needs to come from somewhere. And for the tide to go out, the water needs to go somewhere. And you can think of the depth of the ocean as a doorway that water can move into and out of. If it's shallow, you've got a short doorway, where only a little water can come through at a time. If it's deep, you've got a long doorway, where a lot of water can move in and out quickly. And although that depth changes somewhat with the tides, that doesn't significantly change the size of the doorway in the grand scheme of things. So the moon's natural frequency ultimately depends on how quickly those tides can rise and fall. And the amplitude of that rise and fall is what determines how much heat an object generates. If a moon is getting a gravitational tug at something close to its natural frequency, it can experience some really big waves and generate a lot of heat. But the researchers calculated that Jupiter's tidal pull can only be matching these moons' natural frequencies if their oceans were really thin, around a few hundred meters deep. And as far as we can tell from various observations, they're not thin. They're thought to be up to hundreds of kilometers deep. That's why researchers began to wonder if the moons might play a significant role in heating each other. See, there's something special about these 3 inner moons. For every orbit Ganymede makes of Jupiter, Europa makes 2, and Io makes 4. In other words, the ratios of their orbits are nice whole numbers, so the orbital patterns repeat themselves in a regular pattern. Every time the moons line up with each other, they give each other little tugs. And these tugs always happen at regular intervals, more than once per orbit. In other words, they have a higher frequency than the frequency of tugs from Jupiter. And these frequencies may be close enough to the moon's natural frequencies to create much more significant tidal waves than Jupiter, even though their gravitational pull is so much weaker. Like, in the most extreme case, they could be creating tidal waves 1 kilometer high. And this suggests that not only are moon-to-moon interactions significant, they might be the major thing keeping these objects warm. What's exciting about this is that it shows us what you can learn when you question your assumptions. You can find out about gravitational moon buddies and probe the interiors of distant worlds. And if it turns out to be true that moons can keep each other warm, that gives us all sorts of new places to look for liquid water and life. Thanks for watching this episode of SciShow Space. And while you're here, I want to tell you about the new charity project started by Hank and John Green called the Awesome Socks Club. If you sign up for the club, you'll get a new pair of schnazzy socks each month of 2021. And even better, 100% of after-tax profits will go toward decreasing maternal and child mortality in Sierra Leone, which is one of the most dangerous places to be pregnant in the world. You can subscribe anytime between now and December 11th, but after that, the club will be closed. So if you want to be a part of it, check out the link in the description and sign up today.